Hi everybody. So this is day one of average rate of change. It'll kind of start off with some review of what we know about average rate of change, what you've done within Math 1 and Math 2, and then it'll lead into on the back side of the notes how we can apply this to this year's concepts and this year's functions. Okay, and then there'll be another day two of this just to help with the actual algebraic finding average rate of change with today's or this year's functions. Okay, so remember, stop and pause at any point that you need to copy down what you need to, and then I'll kind of let you know where in here you don't necessarily need to write down if you don't have the notes printed out. If you have the notes printed out, obviously fill in everything, but if you're writing on a separate sheet of paper, some things are not necessarily worth your time to draw out and graph out. Okay. So with the warm up, these three functions are given to you to just kind of help review average rate of change. Remember when you see average rate of change, it means slope. So average rate of change means the slope of the line. To find slope, you're going to need this equation. So slope we use m equals, or the variable m. Remember it's change in y over change in x, and when we talk about change, we use a triangle. Change in y means that you're subtracting your y's, so y2 minus y1 over x2 minus x1. Okay, remember always y over x because it's rise over run. So if you're given two coordinates, we can just substitute it in and we can say m equals. We can call this my x1 and y1. We can call this my x2 and y2. Oops, that should be a y. And y2. Just because the formula says y2 minus y1 does not mean you have to go and subtract this direction. I typically go this direction just because I like to work from left to right. It just means then for the x's, I'm going to have to go the same direction. Okay, so for instance, I'm going to subtract my y's here. So I have negative 15 minus a negative 12 over, and then I have to go in the same direction. So I have to say 8 minus a negative 4. Okay, because I have two negatives here that make a positive, two negatives here make a positive. Notice it's not affecting this side. Okay, so that means I'm going to have negative 15 plus 12 is negative 3, and most of this, this and today's lesson will be without a calculator. Okay, I'll kind of let you know parts that you'll need a calculator. 8 plus 4 is 12. I can simplify that and say that that's negative 1/4. We should always be simplifying. So negative 1/4. Okay. And just to show you guys one time, if I go the other direction, because I always know a lot of people are like, well, the formula says y2 minus y1. Let's say that I were to go the other direction and I were to subtract this way. So then I would say negative 12 minus negative 15. And then I'd have to do the same thing with my x's and go this way. So I'd say negative 4 minus 8. This gives me a positive, so negative 12 plus 15 is 3. And negative 4 minus 8 is negative 12. Notice that this is the same thing. Notice the difference is the negative ended up in the numerator here and ended up in the denominator here. So that's always what will happen. The negative will just move. Okay. Over here, I could do the same thing as I did for the warm-up or for the first problem, and I could identify two coordinates. So I could say, well, I want to use this coordinate, that's a nice one, and I want to use this coordinate, that's a nice one. Or I could use this coordinate. I could use any of these coordinates. I could state them, use my slope formula. However, if I'm given a graph, I really don't have to. I could just count my rise over my run. So notice that my rise here is 1 and my run is 2. So I would say 1 over 2. The only thing you got to be careful with when you count is that you notice that the slope of the line, as I go left to right, I'm going down. So that means that this is a negative. Okay, if I were to pick different points, let's say I were to go from this point down to this point, then my rise would be, let's see, what is that, 1, 2, 3. And then my run here would be 1, 2, 3, 4, 5, 6. So I would say 3 over 6 down negative. And notice that if I simplify, it gets me right back to here. Okay, remember a linear equation is a constant rate of change. So it doesn't matter what 2 points I choose. It's always going to end up simplifying to the same answer. All right. And last one over here. This one over here, it didn't matter which points I chose because this was a constant rate of change. It was linear. Over here, I have to specifically use the points that that I'm told. Remember, this is an interval. Notice they're brackets, not parentheses. Those are both x values. So that's an x, and this is an x as well. So it's saying from the x value of -2, which means from here, to the x value of 1, which means from here. So if I go right here, that would be where x is -2. This would be where x is 1. And I want to know what that rate of change is, that average rate of change, average because obviously it's curved here. Okay, so I want to know what the steepness of that line is. Well, I know that it's negative. Counting's kind of hard here because it doesn't land at a nice point, so I'm actually going to state coordinates. So this coordinate is -2, 30. And this other one is at 1, and we're going to have to estimate about where this is at. This is where 15 is, and this is about in between there. So I'm just going to say 12. Okay, so I would say m equals, I know that I'm going to end up with a negative because my line is going down from left to right. So I'm going to go 30 minus 12, so I'm subtracting my y's, subtract my x's. 30 minus 12 is 18. -2 minus 1 is -3. So this means that m equals -6. You can say -6 over 1 if you want. Notice that the formula always takes care of the negative for me. When I count it like this, I just need to be careful that I recognize the negative. Okay, so those are three different ways that I can find slope. One was by by using the coordinates in the equation. This one was by counting, and this one was by finding the specific points based off of the interval to use the equation. Okay. This part, if you don't have, if you're writing down the notes on a separate sheet of paper, don't feel like you have to do. It's just to talk about a linear equation. Okay. It says consider the function f of x equals 2x minus 1 whose graph is shown. So this is the graph of 2x minus 1. Note it starts at -1, and then notice it goes up 2 over 1, up 2 over 1, or down to left 1 because my slope is 2. It says find the average rate of change of f of x over this interval. Again, remember intervals are always x values. So it's talking about from this point when x is 0 to this point when x is 1, which I can see is 2 because it goes up 2 over 1, which I also know because of this. Okay. This one says find the average rate of change for the interval -1. So this -1 right here would be this point, and 2 would be this point. So if I counted this, I would go all the way like this and like this, which goes up 6. So this distance is 6, and this distance is 1, 2, 3. So my rate of change would be m equals rise 6, run 3, which means that it's 2. Which again, I already knew because of this. I'm just kind of trying to illustrate that. So what can you conclude about this function? It's linear, which we already know because of the fact that how it was written, mx plus b. But we're going to say it's linear, which means there is a constant rate of change. Okay, and this is all things that we should know from Math 1. Okay, so that's just kind of trying to summarize that. Next one here is a quadratic function, and this is going to kind of illustrate what you did last year. So that last problem was to illustrate Math 1. This one's for Math 2. Like I said, if you don't have this written out, you don't really need to write this one down either. All right, so just kind of listen as I go through it. It says to find the average rate of change from 1 to 3. So from x equals 1, that would be this point right here. X equals 3 would be this point right here. Okay, so I want to find the average rate of change of this line, which I can see is negative. So that means I'm going to use the coordinate 1, 0. And I'm going to use the coordinate here, which is 3, -4. So I'm going to say m equals, I need to subtract my y's, so 0 minus negative 4 and 1 minus 3. This is going to change into a positive, so 0 plus 4 is 4. 1 minus 3 is negative 2. Okay, and we're doing all this without a calculator, so just be careful you pay attention to negatives. This means simplified, my slope is negative 2, and again, I always want to state m equals. Okay, next one says find the average rate of change from 2 to 5. So at x equals 2, I would be here, and at 5, I would be here. So I want to find the average rate of change from here to here, which I notice is positive. One of my coordinates is going to be 2, negative 3. My other one is going to be at 5, 0. Order in which I state these coordinates does not matter. So I subtract my y's, which is negative 3 minus 0, and 2 minus 5. Okay, my numerator I get negative 3, and denominator negative 3 as well. This means that my average rate of change is 1. Notice it's positive. Notice these are two different. Okay. Next one, from 2 to 4. So at 2, I would be here, which I already know is 2, negative 3. And at 4, I'm right here, which means I'm finding that. So I'm finding the slope of a horizontal line, which we may already know, but we can always use our equation to justify it. That's going to be at 4, negative 3. So I'm going to say m equals negative 3 minus negative 3 over 2 minus 4. Notice here this is going to change into a positive, which gives me a 0. And then in the denominator, negative 2. This means m equals 0. Remember, I can have 0 on top. I just can't divide by 0. Then it's undefined. That'd be a vertical line. Okay, and 0 does not mean undefined. Does not mean no solution. 0 is a slope. It's a number. Okay, that's okay. Summarize the rates of change in quadratic's formula. All I'm trying to get you to notice is that because these are 3 different intervals, they're 3 different rates of change. So I just want you to state that we can actually make this a little bit slower. We're going to say slope or average rate of change is different for each interval. Okay, again, this is just to point out that this is not a linear equation. It's not the same for every interval, different. All right, and the back side, this is kind of what we're getting to. Notice that we're going to find the average rate of change for each and every single one of these functions listed on this page. We have a quadratic here. We have a logarithmic function here, a logarithmic function here. We have an exponential. What else do we have? Oops. We have a trig function, an rules of exponent one here, a trig function, and a cube root. All right, so we got a lot of good algebra going on this page. To start, it says the slope of a line can be interpreted as rate of change. So every time we see slope, we can think about it as average rate of change or vice versa. Usually we think of average rate of change as slope. For a non-linear graph whose slope changes at each point, the slope between any 2 points is the slope of the line through those 2 points. Oh, sorry, that's redundant. This is supposed to say average rate of change. Average rate of change. So the average rate of change between any 2 points is the slope of the line through those 2 points. Okay, so we're going to have to do some evaluating in each of these. The only way that we can find the average rate of change, so we want to find the average rate of change and we want exact answers only. The only way that we can find the average rate of change is to identify the coordinates that are being used, and then we can use those coordinates with my slope formula. Okay, so you're going to notice in every single one of these, we're going to have to find two points, use my slope formula. Okay, remember this is an interval, so this is an x1 and this is an x2, or vice versa, it doesn't matter. All right, so I'm going to substitute this in. So if I substitute that in, 1 squared is 1. Negative 2 times 1 is negative 2 plus 8. Okay, so that means for the coordinate 1, so for the x value 1, we get, let's see, this is negative 1 plus 8, which is 7. And then if we substitute 5 in, 5 squared is 25, minus 5 times 2 is 10, plus 8. So that means the coordinate 5, let's see, gives us 25 minus 10 is 15, plus 8 is 23. Okay, so all this would be non-calc. All right, so these are my two coordinates. This is what I needed. So now I can say m equals, subtract my y's, so 7 minus 23 over 1 minus 5. Okay, so 7 minus 23 is negative 16 over negative 4, which simplifies to 4. So my rate of change is 4. All right. And then we're just going to keep doing the same thing for the next 5 functions. So if at any point you feel like you want to pause it and try on your own, obviously do so. Or if you want to start the problem with me and then pause it and finish the problem and check your answer, obviously do that as well. Okay. All right. So I'm going to substitute 4 in. So when I substitute 4 in, that's going to give me log. That's weird. That's going to give me log base 2. And 4 minus 3 is 1. Okay, and then when I substitute 11 in, that's going to give me log base 2. Let's see, 11 minus 3 is 8. Okay, so this is good review of the unit that we're going to have to test on when we return to school. All right, so this means, remember, this means 2 to the what power equals 1. And this one means 2 to the what power equals 8. Right, remember if we would say 2 to the what power equals 8, we would say 2 to the what power equals 1. Okay, so what that means is for the input of 4 and for the input of 11, what am I going to get? So 2 to the what power is 1, that would be 2 to the 0 power. 2 to the what power is 8, and that would be 3. So those are my coordinates. So I'm going to say m equals 0 minus 3. Sorry about that. That was my dog barking. All right, and then it's going to be, let's see, 4 minus 11. So that's going to give us negative 3 over negative 7, which means that my slope is 3/7. Okay, and then just remember that we always want to state m equals. All right, let's try another one. Now we're going to do one with a little bit more simple of a log. Remember that this is log base 10, so I'm going to write this out again. This is going to be log base 10. I'm going to substitute the 1 in, which is going to go right here. So log base 10 of 1, and then it's going to be log base 10, and then I'm going to substitute the 1,000 in. So 1,000. Okay, so that's going to give me my two coordinates. So when x is 1 and when x is 1,000. Okay, remember this is saying 10 to the what power equals 1, and this is saying 10 to the what power equals 1,000. Okay, so I'm going to write that out just so we can see it. I didn't give myself space to do that. So it's going to be 10 to the what power equals 1. This one over here is 10 to the what power equals 1,000. So this would be 10 to the 0 equals 1. So substitute in 1. So input of 1 gives me an output of 0. This one is 10 to the third power, gives me 1,000. Okay, so I can use those coordinates now to find my average rate of change. So I'm going to do 0 minus 3, and I'm going to do 1 minus 1,000, which gives me negative 3 divided by negative 999, which can simplify to positive 1 over 333. So I can divide each of those by 3, and this would be my simplified answer. Okay, so everything we've done so far hasn't needed a calculator yet. I believe this one might though. So let's see. If I substitute 0 in, that's going to give me 3 to the 0 minus 2 is negative 2. If I substitute 5 in, 5 minus 2 is 3. Okay, so remember, when I raise to a negative power, it's the reciprocal answer. So when I substitute 0 in, this is going to be when I substitute 5 in. So if I ignore the negative, 3 squared is 9. The negative means the reciprocal of 9, which is 1/9. Okay, that I'm doing without a calculator. All right, and then over here, 3 to the third is 27. Okay, again, notice this theme in every single problem. I have to get my two coordinates, and once I get them, I can use my slope formula. So I'm going to have 1/9 minus 27 over 0 minus 5. Okay, and then I'm going to do this with a calculator, so let me grab the calculator. Okay, so I'm going to put my calculator. I want to make sure that I state that my numerator is 1/9 minus 27. I don't have to put parentheses around the 1/9 because order of operations, it's going to do the division before the subtraction anyways. And then I'm going to divide by 0 minus 5 is negative 5. Okay, it's going to give me this. I'm going to change it, so I'm going to hit math, change to a fraction. Notice that it's using this triangle as a change, which is why it's changing y or changing x with the triangle as well, just so you know. Okay, so that's going to give me that my m is 242 over 45. So that's the first problem that we've had to use our calculator for. All right, let's try another one. And again, pause at any point. Trig, oh, there's 8 problems on here, sorry. Trig is something that we probably forgot about, so this will be good to review for the final when trig comes back around. Sine, remember, is talking about our y values. So sine y. That was a terrible y. Okay, so if I input, I'm going to input these into here. So that means it's going to be sine of pi over 6, and it's going to be sine of pi over 2. Okay, so if I draw out my unit circle, remember pi over 6, the 6 means that it goes with a 30-degree angle, and 30 degrees is right here. So what this means is at pi over 6, my y value, remember y value, that height, that little height is 1/2. At pi over 2 is up here at 90 degrees. My y value there is 1. So at pi over 2, my y value is 1. So those are my two coordinates. So I'm going to say m equals 1/2 minus 1 over pi over 6 minus pi over 2. Okay, and this one we're going to have to do some work with the pi's. So 1/2 minus 1 is negative 1/2. I have to get a common denominator here. My common denominator is 6, so that would be pi over 6 minus, if I multiply this by 3, that's going to give me 3 pi over 6, okay, which means that my denominator, this is 1, so 1 minus 3 is negative 2 pi over 6. And I could simplify that, but I'm going to hold off for a second, because you're going to see why. I'm going to multiply by the reciprocal now, which means I'm going to multiply by negative 6 over 2 pi, so that goes up there, okay. And I can simplify this, or I can multiply it and then simplify. It's up to you. I'm gonna multiply it actually first. So negative 1 times negative 6 is positive 6. 2 times 2 is 4 pi. Okay, that can simplify. I can divide both of these by 2, which is then going to be 3 over 2 pi. And that would be my answer. Okay, I'm actually going to do the one below this next, since sine and then this next one's cosine. That way we can do these two together. Okay, so in this one, remember, cosine is talking about your x values. So we're going to substitute both of these into our x value here. Okay, so we're going to say cosine at pi over 2, and we're going to say cosine at 2 pi. And remember, if you guys are doing this on a separate sheet of paper, you want to make sure you write down the problem and show all this work. okay? What I tend to see with this when I'm in class is I tend to see a lot of people have answers with very little work, and you can see how much work this takes to get the coordinates and then how much it takes to use the coordinates to find the answer. So you want to be making sure that you're showing each and every one of these steps, mostly to eliminate errors, but also to justify your answer. Okay, so I want to know my x values. So when I look at this and I plot these, pi over 2 again is up here. So let's see. When I have an input of pi over 2, my x value here is 0. So notice we're pulling our x values now. And 2 pi means that it would go all the way around in here. So for an input of 2 pi, my x value is 1. Okay, so again, x values. So I can now say m equals 0 minus 1 over pi over 2 minus 2 pi. So my numerator is -1. My denominator, I'm going to get a common denominator. So this is over 1, which means I can multiply it by 2. Okay, that's going to give me 1 pi over 2 minus 4 pi over 2. So 1 minus 4 is -3 pi over 2. Okay, I'm going to multiply by the reciprocal. Multiply by -2 over 3 pi. Okay, that's going to give me, it's a lot of messy work here. That's going to give me -1 times -2, which is 2. And then remember, there's a denominator of 1 under here. So 1 times 3 pi is 3 pi. Nothing needs to be simplified, so I'm just going to state that m equals 2 over 3 pi. Okay, again, remember, state what m is. All right. Let's go back up here. Let's see. These ones you might want to do by yourself. They're not too bad. But again, you can always watch as well and follow along and write down. So I'm going to substitute in a 1, and there's not too much work I need to show here. When I substitute 1 in, 1 squared is 1. So 1 over 1 is 1. And when I substitute a 4 in, 4 squared is 16, which means that I'm going to get 1 over 16. So m equals 1 minus 1/16 over 1 minus 4. Okay, and I'm going to use my calculator here. Yeah, I'm going to use my calculator here. So I'm going to say 1 minus 1/16, and again, I don't have to put parentheses around the fraction because it's going to do division anyways, divided by -3 gives me this, which I can change into a fraction, and that way then I can say that m equals -5/16. All right. All right, this would be a good one to try on your own if you haven't yet. I'm going to write some of this out. The more steps there are, the less mistakes I want to make because there's a lot of opportunity here. If I substitute a 2 in, let's see, 2 times 2 is 4. 4 minus 5 is -1. And then be careful you don't lose that +1 on the outside here. Okay. That is going to give me, let's see, the cube root of -1 is -1. So that's going to be 4 times -1 plus 1. And you don't have to show all of this work, but I just want you to see where it's coming from. So that means that the coordinate 2 is going to give me an output. This is -4 plus 1, which is -3. If I substitute 16 in, let's see, 16 times 2 is 32. 32 minus 5 is 27. And then the +1 is on the outside. So that's giving me 4 times. The cube root of 27 is 3 plus 1. And all of this is definitely without a calculator. That means the input of 16 is giving me, let's see, 12 plus 1 is 13. Okay, so I'm going to say m equals -3 minus 13 and 2 minus 16. Okay. Up in my numerator, I get -16. and negative 14. So those can be simplified. It's going to be positive. And it's going to be 8/7. There we go. All right. And is that it? That's it. Okay. Let me get rid of this. Let's see here. Okay. Your homework just has a lot of the same. Take your time with it. You guys are going to have, remember, you don't need to get this done necessarily tonight. If you want to span it over 2 days, you're going to have all that time over spring break where you're probably going to be looking for something to do. I'm not condoning you guys putting this off. I'm just saying if you want to spread this out over maybe 2 days, 3 days, take your time with it. You don't, need to get it all done in one night. But each of these is just going to go through rate of change, and it's going to be a lot of evaluating and just different ways that you guys can see the same question as different ways. Okay, so you're going to see like this first one, it's a cubic function. It's going to say find the average rate of change over this interval, find the average rate of change over this interval, find the average rate of change over this interval. So you have 3 different intervals that you're doing for the same function, and then draw a sketch of the function. This is review from way back in our first unit of the semester. No, first unit of the year. It just has to do with you factoring by grouping because there's 4 terms. And then once you find the solutions from your factoring, you can show the direction and everything on where it goes. Okay, and I'll probably actually do this one with you when I do the next lesson. Over here, you have natural log functions for an interval, just a different way you can write an interval. Same thing there, you have log function, and then here you have an exponential function, okay? And then the backside is going to look just like the notes, where you have 2, 4, 6, 8 problems. All the answers are on the back page. But notice you have trig here, you got trig up here, you got a cube root here, a log there. So it's really good review of logs and trigs and rules of exponents. All right, cool. And then we'll do a day 2 tomorrow. All right, thanks everyone.